So at the top of page 573, you can write solve for theta. And that's as high as I can lift my arm, so I'll just scroll so that that's the top of the slide for me. Okay, solve for theta. We're going to do some calculator questions first. So all of these ones would appear on a calculator part of your test. And you would get a question like 3 sine theta equals, let's make it negative root 2. So how do we go about solving this? We're going to assume that all of these solve for theta questions, we're going to solve them over the following domain. So every time you get a solve question, you're going to get a domain over which you're going to solve for it. The odd time that no domain is stated, that means you have to solve for every single real number possible. And we're going to get to that, but we're not going to get to that until a little bit later in this lesson. So if you had solved for theta between 0 and 2 pi, that means once around the circle. And here's a calculator question where 3 sine theta is negative root 2. So this is the same kind of question you would have had in a grade 10 or grade 11 class. You would have isolated sine by dividing both sides by 3. Now what we're going to do this year is you would take a moment to look and say, is that on our pi plate? It's close. We have root 3 over 2, but we don't have root 2 over 3. So this one is close to being something that's on our pi plate, but it's not. So how do we solve ones with our calculator that are not on our pi plate? Well, here sine is negative. That's telling us something. That's telling us that our answers for theta, according to the cast rule, it has to be either in quadrant 3 or quadrant 4. And sometimes, and this is an option, but sometimes it's very helpful to draw a picture of what's happening and to draw a triangle, because here would be our reference angle. And since sine is opposite over hypotenuse, if we made a triangle, we would say, well, I know my hypotenuse is 3, my opposite side is root 2. And I'm labeling these all with positive values as if I was measuring the length of those sides of those triangles. If I wanted to find that reference angle, I just have to use SOHCAHTOA. I have the opposite side of the reference angle. That's positive root 2. The hypotenuse is 3. And so now I can go to my calculator and do sine inverse of square root of 2 divided by 3, and I get a reference angle of 0.49. I'll just put dot, 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 because we won't want to round our answers until the very end. You might even want to take that value and store it in your graphing calculator as x, so you can use it multiple times. So then in quadrant 3, if we want to find out what the answer is, well, you would have to go, in degrees, you'd go 180 plus that reference angle. So in radians, you're going to go pi radians plus your reference angle. So if I go to my calculator, and since I've stored it as x, pi plus that reference angle comes to 3.63. And now I can round it according, sometimes they'll say round to the 2 decimal places or round to the nearest hundredth. So that's rounded to the nearest hundredth. If I wanted to go to quadrant 4, well, in degrees, I'd do 360 minus my reference angle. So in radians, I'd go 2 pi radians minus my reference angle, and I get 5.79 as my second answer. We'll call this question 1. We'll do 3 questions with 2 questions with our calculator and 2 questions without our calculator. So there's question 1. Question 2, I'll give you some time to try it on your own. (8 tan theta plus 3 equals 0. So first of all, you'll get tan by itself. You should have got negative 3/8. If you want to draw the diagrams out, because tan is negative, it would appear quadrant 2 or quadrant 4, and you could label your reference angles. Then to find your reference angle, so when we draw those actual triangles, it becomes apparent why we're using positive values. Because when we use positive values, those are the actual measurements of those triangles, and we're trying to find the actual measurement of that reference angle. That's including positive values. Your calculator does calculate the negative values if you plug them in, but we haven't understood exactly what happens when we do that. So when we do tan inverse of 3/8, you get a reference angle of 0.36. Then in quadrant 2, you do pi minus that reference angle to get 2.78. In quadrant 4, you'd go 2 pi minus that reference angle to get 5.92. So those are our two calculator questions. Now we're going to do two questions that are non-calculator. Question number 3. Non-calculator and calculator is going to start off the same way, right? You still need to get either whatever trig function you have by itself. So I'm going to move this 16 over and divide by 4. So I would get 16 divided by 4, which simplifies to just 4. Now, when it's a non-calculator question, what you're expecting is you're expecting a value that's on your pi plate, something that you recognize. So you're expecting like a 1/2 or root 3 over 2 or 0 or 1. So this question sometimes throws you off for a moment on a non-calculator question because 4 is not on your pi plate. It's not one of the values. So you're like, whew, well, maybe I'll draw a picture. It's positive, right? So it could be in quadrant 1. And if you draw a picture with your reference angle in quadrant 1, well, I got to make this a fraction. So the adjacent side is 4 and the hypotenuse is 1. And sometimes when you draw that picture, you're like, oh, wait a minute. How can my hypotenuse be less than my adjacent side? And that might trigger you to say something's wrong here. That's why this is a non-calculator question, because this is not possible. And all I'd have to do is once I recognize that it's not possible, I just write that down. I somehow have to indicate that there's no solution to this, and we're done. So that's pretty straightforward. Other non-calculator questions do look like, here I'll do it. This, I'll think of the hardest non-calculator one that I can. There we go. Root 3 tan theta minus 1 equals 0. Because I have seen this on a final exam with questions that appear like this. So first of all, we have to get tan by itself. When we get tan by itself, we move the 1 over. And divide by root 3, and we get 1 over root 3. Now, if you've memorized your pi plate for your tan values, you might have memorized root 3, 1, and root 3 over 3 as the 3 key ones that are on tan. And this doesn't match with any of those directly, right? Because this is 1 over root 3. You have root 3, you have root 3 over 3, but if you memorize them that way, you don't have 1 over root 3 on your pi plate. But what can you do with 1 over root 3? You can rationalize the denominator by multiplying the top and bottom by root 3, and you find out, oh, this is the same as root 3 over 3. So if this is the same as root 3 over 3, oh, this is question number 4. Then we have to think, well, what family is that? That's our pi over 6 family. When is tan positive? Tan is positive in quadrant 1 and in quadrant 3. What's our pi over 6 family member in quadrant 3? 7 pi over 6. One more than the denominator. and then that one would be done.